This image shows the typical construction of tyres. Tyres take the full weight of the aircraft and therefore need to be very strong. Tyres may be manufactured with tubes or without tubes. The current design is for tubeless tyres to be used. As the name suggests, a tubeless tyre has no inner tube and radial side casing. Solid or branched wheels are used. The advantages of a tubeless tyre. It weighs less than a tubed tyre. No heat is generated from internal friction between tyre and tube, therefore the assembly runs cooler. And there is less deflation risk from punctures. Ply rating is an index of tyre strength. It originally related to layers of cotton and rubber which were layered up, giving a ply rating for the tyre. Nowadays, it does not necessarily represent the number of plies used in the construction of the tyre. Thermal fusible plugs. These consist of a steel outer shell with fusible material in the centre of the plug, fitted into the wheel rims. If the wheel becomes excessively hot, the fusible material melts, releasing the air pressure, and the tyre deflates. The plug allows for controlled deflation rather than a blowout. Tyre treads. These provide indication of wear, grip, and a means of displacing water. A block pattern, for example square or diamond, is suitable for unpaved and paved areas. A ribbed pattern is suitable for hard concrete surfaces, has good traction and braking, and increased hydroplaning speed over a smooth tyre. Chines are used to deflect water spray away from the aircraft structure. Tyre creep is the tendency for the tyre to slip, physically rotate, around the wheel. With regard to tyre wear, it's very important that inflation pressures are kept at the correct level. Underinflation will lead to wear at the shoulders. Overinflation will lead to wear at the crown. Tyre treads may be repaired several times, however damage to sidewalls and plies is not acceptable. Shimmy is an oscillation of the nose wheel from side to side on the ground. It has the potential to cause damage. A shimmy damper on the steering cylinder is used to reduce shimmy. Hydroplaning occurs when the tyre loses contact with the surface and slides on a thin film of water. The friction factor is now 0. If the depth of water is greater than 3 mm, the possibility of hydroplaning is high. Hydroplaning speed in knots may be calculated by taking 9 multiplied by the square root of tyre pressure in psi. Operational considerations. Ground manoeuvring imposes the greatest stress on the wheel tyre assembly, so taxi slowly. Use minimal braking and the largest turn radius possible. Wheel fires can occur if brakes are very hot and oil or grease is present. If possible, use dry powder to extinguish. Only approach the wheel from the front or rear, not the side in case the sidewall blows out.